In this example, we are going to analyze an energy equation or energy function. So with the information given, they already found the function for us, but we will figure out how they got this function, okay, first with the given information. Okay, it says a bird is released from point A on an island 5 miles from the nearest point B. So this is my point B and that's my point A, and the distance between the two is 5 miles, and a bird is released from a point A on a straight shoreline. So the bird is released from here. So the bird flies all the way up to point C, right? And then on the shoreline, the bird is flying to its nesting area at D. Okay. The other information given in the question is the bird requires 8 kilocalorie per mile to fly over land. So this is the land speed, and also it requires 10 kilocalorie per mile to fly over water. This is the other information given in the problem. Okay, now imagine if this equation was not given to me, I should be able to write this out. Okay, and in order to write this, the formula that has been used is the energy used is equal to the energy per mile times the miles flown. So first we need to know the distance, miles, right? So that's what this filling the blank spaces in here would be. So for that, to begin with, the question is saying, like, say for example, if you say x is the distance from point B to C, so they already gave me x is the distance from point B to C, then the distance from point A to C is what? This is where the question mark is, right? So let me come back to my picture. So this point A, point B, point C looks like a right triangle, and I know that this length is x, the horizontal length is x, I know this length is 5 miles, so I can find the hypotenuse using the formula c squared is equal to a squared plus b squared, right? Pythagorean theorem. So therefore c would be square root of a squared plus b squared. Now a could be x and b could be 5, or b could be 5, x and a could be 5. Either way, it's going to be square root of x squared plus 5 squared, which is 25. And that is what this should be, square root of x squared plus 25. Okay, and the next part of it is the distance from C to D. So C is here. Let me use another color so we can see the difference. Okay, here it is. So C is the point here and D is the point here. Now I need to find what this distance is. Now I know this whole distance given to me is 12. And then I also, from this information, another thing that where is it? I don't know what's erasing. Okay. So this is given to me as 12. Now I know this length is x, right? That length is x. Therefore this length can be written as 12 minus x. And that's what this should be, 12 minus x, okay? And the and the distance from C to D is 12 minus x. The energy used in flying from A to C is, so again formula goes energy is equal to energy per mile times miles flown. The energy per mile on land is given to me and water is given to me, right? So from A to C, it is the energy per mile on water. So therefore the energy used would be 10 times square root of x squared plus 25, and the energy used in flying from C to D would be the energy that it's flying by land, which is going to be 8 times 12 minus x. And therefore if I add them together, my equation for energy will end up to be what they have shown there as E of x equals 10 square root of x squared plus 25 plus 8, 12 minus x. Now when I come to this point here, immediately I know my dependent variable is the energy and the independent variable is going to be x, which is the distance, right? Distance from point B to C. Okay, so now the next part of the question B is asking if the bird chooses to a path that minimizes the energy expenditure, to what point does it fly? To what point does it fly? So technically what it says is if I take this energy equation and graph it, I might graph a point where I'm going to have a minimum value or a minimum E value, and it's asking what this x is. That's what the question is. Okay, so in order to do this particular problem, the best bet would be to graph this function. So I'm going to put this y equals the way it is here, 10 square root of x squared plus 25 plus 8 parentheses 12 minus x close parentheses. And then, we are talking about distance, so I don't have to worry about what is happening on the right hand side. So I'm going to keep that 0. This is 10 and scale is 1 for right now, and then this maximum is 0 too. I'm going to graph and see what I'm going to see here. Okay, okay, so this is very clear. Since I have nothing in here, it is telling me that the graph is there, but my window is not proper. So I am going to first, and this is a good thing to do to start with. If you have no clue where the graph is, then you can begin with just by hitting zoom fit. This sometimes might bring you to partially to view the graph. You may have to still adjust the window again, but at least you will see a little portion of the graph. Now when I look at this graph, and I'm looking for a minimum point, so I can see the minimum point, but I need a little bit more clarity on seeing where the point is. So it looks like my graph, if I can, my y minimum was 0. So if I can increase that, maybe I can see the minimum value. So going back to window, y minimum, oh no, it changed to 126. So I'm going to keep that 0. And maybe x minimum, I will go to probably 10, let it be a 10. And then this I'm going to change it to 100. Now there's one more thing I didn't mention here is the implicit domain of this function. So let me talk about that before finishing up the graph. So when I see this function, I know that my domain is so for me, I definitely know 12 minus x must be greater than 0, right? So in that case, negative x is greater than negative 12 or x is less than 12, right? So I cannot have a value of 0 like less than 0. So if I think of my number line, I would say my x has to be greater than 0. So from 0 to 12 is my domain of this function. So if I say the domain would be 0 comma 12, not including 0, and if it's 12, it's reaching the extreme endpoint, so between 0 and 12. Okay, so this is also sometimes helping me to decide what kind of x maximum can I give. So I can change my x maximum. Instead of 10, I can call it 12 here. Okay, so now I can see the minimum point. So I would again, because it's asking me to round my answer to 1 decimal place, it's better for me to change my window setting, delta table set, to probably 0.1. And then also if I want, I know that it has to start at 0, right? So if I go back to my graph, these are again adjustments that you can do depending on what you're looking for, right? Okay, so in the x-axis, 0, like, so this is 1 2 3 4 5. So for me, I need to mostly look at from 5 to 6, 7, 8, 9, right? 9, 10. 5 to 9 is what I'm looking for. So I can go and change my x minimum to 5 and an x maximum to 9. And since I changed my delta table set, it doesn't matter. I can look at the graph now again a little bit more clearly. Okay, so another way to look for the minimum point very specifically is going to the table. So hit second graph, which will take you to table. And now I'm looking for the smallest y value. So keep going on the right, keep going. I have a 331, 131, 130, 130, 129. It's still decreasing. I'm looking for the smallest point. So decreasing, keep on decreasing. Okay, I'm going. Okay, so 126.01, 126, keep on going. Yes. So see here, I have a 126.01 and then I have a 126.01 over here. So in between, this is my smallest point. So if I have to graph this, I would say the smallest value is x is 6.673 comma 126. That is the smallest value that I can get. Okay, and that's the point I was looking for. So the question is, if the bird is choosing the path, and what point it would fly. The answer would be, rounding to 1 decimal place, it would be 6.7 miles. Okay, I hope you understood this. Again, graphing calculator usage is something you can, look around for videos, just play around. Most of the time you can see all the information through the graph, but sometimes when you have to be more accurate or go into more decimal approximations, then it's better to use the table. But at the same time, it's better to set your table set also. You can change this. If I need more accuracy, I can change this to like 0.0001 or like depending on what the value is. Now because it was saying 1 decimal place accuracy, I just went 0.1. And that's something, depending on the problem, you can move it around.